Hi everyone, welcome to one of our first videos here in chemistry. It's called Physical versus Chemical Properties and Changes. You'll need your notes, which is just your pen and paper for this. So we're going to talk about the definitions of physical and chemical changes and properties and their examples. So the first part are physical properties. So we can observe them with our senses, and we don't have to actually mix it with anything else in order to see what the properties are. Chemical properties, however, we actually have to see how it reacts with another substance. So we have to combine it with something in order to see what happens. If it does change chemically, it's going to be a chemical change. And we should use chemical equations to help us figure this out. So from some physical properties, you've seen these since elementary school. Their color, their smell, their shape, the mass, length, the taste, of course not in lab, luster, which is how shiny it is. You can see that this piece of metal is very lustrous. It has a lot of shine to it. We can also see how malleable it is, so we can hammer them into shape or into flat sheets like for this copper. We can also stretch them out, which is seeing how ductile they are. So we can, in this case, still copper, we can actually draw down to wires, and that's actually really useful because we use copper wiring for supplying any of our electronics. It has a great conductivity of electricity. We can look at their boiling point, melting point, or their density as well. So these are all physical properties. Let's take a look at chemical properties. This we actually have to look at the composition. So let's take this penny for example. If we were to break apart the penny, we would see that there's actually a zinc core. It looks like a silvery core. It's actually zinc. About 97% of copper pennies made after 1982 are made of zinc. Only about the outside, the 3%, is made of copper. But let's take a look at the copper itself. So the composition of copper, if we take a look through a scanning electron microscope, something that we definitely don't have in lab right now, but we can actually see that each of those spheres are copper atoms. We have to scan that in really into it, scan it a lot. If we were to able to scan it even further, we can actually see a picture of what the atom is made of. And the atom is made of protons and neutrons, that's in the center or the nucleus, and then they're made of electrons on the outside of that nucleus. So that's what a copper atom is. So to look at the chemical property of this penny, we would have to look at its composition. That's made of copper, and copper itself is made up of protons, neutrons, and electrons. Let's talk about physical changes. These are any changes in states of matter. So we can have melting. Here we go from a solid water to liquid water. So you see this chemical equation here. We have H2O solid and then an arrow. That arrow means that it produces H2O liquid. The H2O, of course, is water. The only difference between the left and the right-hand side of that arrow is that little letter, or those two little letters down at the bottom. So if we see here, we have an S there and an L there. That S stands for solid, the L stands for liquid. So in the picture you see that you have ice melting. You have that solid ice, which is right here, and then it starts to form little puddles of water all around it. That's the liquid part of it. We can go in the opposite direction as well. We can freeze them. So we can go from liquid water to solid water. So these are chemical equations. You can also note that on the left-hand side versus the right-hand side, the only thing that changes is that state of matter right there, liquid to solid, or before solid to liquid. The actual compound itself is staying the same. It's still going to be H2O. Let's take a look further. We can take H2O liquid, heat it up, and form H2O gas. So that's boiling or evaporation. Again, the only thing that changes from the left to right-hand side are those little states of matter. The chemical compound itself doesn't change. The opposite of boiling or evaporating is condensation. Again, going from gaseous water to liquid water. You don't change the water itself, but you do change its state of matter. So looking at this little diagram, going from a solid to liquid to gas, you can see all the little different parts of the phase changes. Make sure you know those as well, so jot them down if you need to. Another physical change is dissolving. So we can mix something with water, or you can have two gases mixing together. We generally don't have two solids mixing together, but you can kind of, a physical change of that might be like a mixed salad or something like that. You can definitely take them apart still. So in this case, and this is something they do need to know as well, mixing with water, we call that aqueous. So if we were to write it out as one of these little states of matter, it would just be AQ. And that's supposed to be a Q right there. All right, so if we mixed something with water, that's called aqueous or aqueous. This is still a physical change because we haven't changed the composition of the substance. So say, for example, if you take sodium chloride, NaCl, which you should know is table salt, if it's a solid, and I add water to it, that water would be in a liquid state. I can still draw this arrow. I can show that I still have NaCl, except in this case, when I mix NaCl and water, I get an aqueous solution of NaCl. And there's still water hanging out in there as well. It's just mixed in. So I haven't changed the substance itself, but I've changed its state of matter. We could reverse this. So if I needed to take that NaCl out of the aqueous solution, I could just evaporate out the water and then still get solid NaCl at the end. So this is a physical change. So again, we have any states of matter. Mixing with other substances would also be a physical change. So in this case, this is the cell that we see as well. Chemical changes, we actually have to change the composition. So let's take a look at this chemical equation. We have a whole bunch of different things going on in here. We have something called CH4, which is methane, O2, which is oxygen. That arrow again, meaning if you mix methane and oxygen, it will produce CO2, carbon dioxide, and water. So we can actually take a look at writing it out essentially. So you see that methane reacts with oxygen, so you see that word reacts with in there to form carbon dioxide and water. That's the key for any chemical changes. If you see reacts with, then you know it's a chemical change. Let's take a look at this particle diagram down below. We have methane, which is our CH4, so the black sphere is your carbon, little white ones are hydrogens. You're adding that to oxygen, so these red spheres are oxygens, and it's producing carbon dioxide and water. Alright, so those are the particle diagrams. You see from the left to the right hand side, before that C was matched up or paired up with the H, now it's paired up with the oxygen. So the chemical composition has changed, meaning that these elements are mixed up or changed or combining with different elements in there. You might also see fizzing or bubbling as some examples of chemical changes. Here we have Alka-Seltzer in water, you have CO2 being produced at the end. And really disgusting looking picture, this is rotting or decomposing. You can also see this is a chemical change because if we took a look at a chemical equation for this, you would see that you end up having certain substances decompose or break down into other substances. So that sugar, the sucrose in there, might be breaking down into some other particles. To summarize, if you see any chemical changes, if you see the words reacts with, you know it's a chemical change. You can also add in combusts as well in there, so you can also note that as a chemical change. Let me write that in there for you. So chemical change would be reacts with or combusts, or combustion. This just means it's producing a lot of heat at the end. Physical changes, on the other hand, are any changes of states of matter or dissolving. So I hope you guys have a great day. Take care.